Hi everyone, what's up? Welcome back to my tutorial channel. It's Daniela Tran here, and today we are going to work on some more practice problem of the IFM exam. This video is section 4-2 advanced level. Alright, so let's get started. First question. A corporation is considering an investment in one of the two potential projects. Its project requires an initial investment of $5,000. Project X will produce cash flows of $300 at the end of its 6-month period. The cash flows are expected to continue forever. The first cash flow is expected 6 months after the initial investment. Project Y will have a single cash flow of Z, which will be received exactly 5 years after the initial investment. The IRR on both projects is the same. Determine Z. So, for this problem, first of all, we have to use Project X to determine the IRR. Then we have to use the IRR to determine Z. So let's take a look at Project X. The net present value NPV is equal to minus 5,000 plus 300 times with V to the 1/2 plus V plus dot dot dot. Here, first we have to invest 5,000 at time 0. That means we pay 5,000, so we lost $5,000 at time 0. That's why we have minus 5,000. And at the end of each 6 months, we got $300 back. So this is the way that we write the annuity. And this is an infinity annuity. So we don't have the ending number. And just follow the formula. We got this is minus 5,000 plus 300 times V to the 1/2 over 1 minus V to the 1/2. And then in the fraction, in order to simplify it, I divide both numerator and denominator by V to the 1/2. So I got $300 over V to the minus 1/2 minus 1. And we want to break even this project. So we set the net present value as equal to 0. And we solve for V. And from V, we can solve for IRR because V is 1 plus IRR whole thing to the negative 1. So V to the minus 1/2 is just 1 plus IRR to the 1/2, and it is equal to 1.06. From here, we can find out that IRR is 12.36%. Again, I repeat, from the equation of NPV is equal to 0, we can solve for V. And from there, we can solve for IRR. And we got IRR is 12.36%. But that is not what the question asks for. The question asks us about the single cash flow of Z. So we have to apply IRR to project Y in order to produce Z. So let's look at project Y. The net present value is minus 5,000 plus Z, V to the 5th. And from here, we solve for Z, which is 8954.23. So that is Z. Problem 2. A new Bitcoin mining software is expected to mine at the rate of 0.005 units of Bitcoin continuously per year. The price of this mining software is $4,999, and the market price of 1 unit of Bitcoin is currently $6,300. The market price of Bitcoin is expected to grow at the rate of 7% continuously per year. You decide to invest in this mining software. You will immediately sell any Bitcoin the software generates for cash. The continuously compounded cost of capital is 7.5% for the investment. Determine the break-even time in a year. So here for this investment, first of all, we have to pay for the mining software, which is $49.99. And this software mine at the rate 0.05 unit of Bitcoin, with the market price for one Bitcoin is 6,300. And we have the market of the Bitcoin rate is roll at the rate of 7% continuously per year. And the cost of capital is 7.5% continuously per year. So before we work on this problem, I want to recall a formula for the growing annuity. 1 over r minus g times 1 minus e to the g minus r times n, when n is the number of years. And this formula is for the net present value of the growing annuity. So, and r and g here are the continuously compound rate of change. So in this problem, g here is basically the cost of capital, which is 7.5% or 0.075, and r is the growth rate of the Bitcoin. And from here, we write out a formula of the NPV. We pay $49.99 at the beginning when we invest into this project. So it should be minus $49.99. Then let's say the mining software mine at the rate 0.005 unit of Bitcoin continuously per year, and the market price of it is 6,300, and we don't know exactly what time we invest in. So it should be 0.005 times 6,300 over r minus g times e to the minus r minus g times n with minus sign. And then we sell the Bitcoin of the software generate for cash immediately. So we should have 0.005 times 6,300 over r minus g. And combine them all together, we got 0.005 times 6,300 over r minus g times 1 minus e to the minus r minus g times n. And from here, g is 0.075 and r is 0.07. We solve for n. So n here should be 315.5, which means the break-even time in years should be 315.5. Problem 3. Consider a 2-year project where the cost of capital is 10%. There are only 3 cash flows for this project. The first occurs at time t equal to 0 is negative 100, and the second occurs at time 1 is 66. The third occurs at time 2 is x. Determine x, the level of cash flow at time 2 that lead to the project breaking even. So similar. For this problem, we have to write down the NPV. The NPV here is first at time 0 is negative 100, then at time 1 is 66, and the present value of the 66 at time 1 is 66 over 1.1 because the cost of capital is 10%. And at time 2, we got the third occurs, which is x. But because x occurs at time 2, so the present value of x is x over 1.1 squared. And setting the net present value at, of this project as 0, we solve for x. So x should be 48.4. So the project break-even x, level of x, should be 48.4. Problem 4. Company XYZ is offered a loan of $50,000 with principal repayment at the end of 2 years and 5% interest paid at the end of each year. Assuming the opportunity cost of capital is 6%, what is the net present value to company XYZ of the loan? So first of all, when the company XYZ offer a loan, 50,000. So we got 50,000 at time 0 is what we have to pay. Now at the end of each year, we have to pay 5% interest. 5% of 50,000 is, we take 50,000 times 5%, which is 2,500 or 2,500. And we have to consider the present value of each of these cash flows. So let's write out the NPV. At time 0, we receive 50,000 because the company gives us 50,000. So it should be positive. Then at time 1, we pay the company 2,500. So it should be negative. And the present value of this amount is 2,500 over 1.06. At time 2, we pay another interest and also the principal, which means at time 2, we have to pay the company 52,500. And the present value of it should be 52,500 over 1.06 squared. And use calculator, we find out that the NPV here is 916.7. Problem 5. Project P requires an investment of 4,000 at time 0. The investment paid 2,000 at time 1 and 4,000 at time 2. Project Q requires an investment of X at time 2. The investment paid 2,000 at time 0 and 4,000 at time 1. Using the net present value method and an interest rate of 10%, the net present value of the two projects are equal. Calculate X. So here, both projects have the same interest rate, 10%. So I'm going to set V is equal to 1.1 to the negative 1 because V is 1 over 1 plus I. I here is 10%, so V should be 1.1 to the negative 1. This is the basic calculation in exam IFM. And now, since two projects have the same net present value, so I have net present value of P is equal to net present value of Q. Net present value of P is minus 4,000 plus 2,000 V plus 4,000 V squared, because at time 0, we have to invest $4,000. At time 1, we receive 2,000, and at time 2, we receive 4,000. Similar for project Q. At time 2, we invest X. That's why we have to subtract X. Time V squared for the present value. At time 0, we receive 2,000. And at time 1, we receive 4,000. And then here V is given as 1.1 to the negative 1. And X is not given. This is an equation of X. And this is a linear equation. So go ahead and solve for X. We got X is 5460. Alright, so that's it for today. Thanks so much for watching. I hope you guys like this video. Please like, share, and subscribe. Goodbye.